On your lap.
He's so funny. Whenever I sit down to do homework, he's like, no, let's play. Doesn't matter that we just went for a walk in the rain before this started. You know.
Okay, so we're on question 6.
Okay, yeah.
And we kind of already got the answer. Or at least
Okay.
we got it. If you want to, it's just that it's the z-score.
Okay, yeah, I'll figure that one out, and then we can move on to 7.
You
Do
sure?
you guys understand like why we calculate z-scores? Because that can be helpful in because as we go on throughout the course, there's going to be a bunch of different formulas. So if you're just memorizing the formulas by themselves, it might be hard for you to keep track of them, and it might be easy for you to mix them up during a test. But if you understand why we get the formulas, then it'll be easy for you to remember the formulas itself. So do you understand why we calculate these scores?
Nope.
No.
No.
Right?
I think I do.
Okay, Cameron, explain it to us.
So I think the z-score is important because it lets us know how far away that one data point may deviate from the mean.
Perfect. Yeah, that's a great way of putting it. So, do you guys remember in that lesson when we learned about these scores, we talked about I think there was a Kenyan woman and guy from Holland or whatever, or Finland.
Mm-hmm. The average height.
Yeah. So obviously intuitively we know that it's not really fair to compare the Kenyan women versus the Finnish man, right? Because it's like apples to oranges. So really, we want to compare the Kenyan woman to other Kenyan women, and the Finnish man to other Finnish men to see how tall they are compared to their groups, right? So that's why we use z-score. We want to, if you just give us x, she is 5 feet tall. It's not very meaningful to us. Well, how tall is she compared to other people that's like her? That's what the z-score tells us.
Because then if you have a really high z-score, you know that they're way taller than everybody else.
Exactly. So
Makes sense.
once you have the understanding of z-score, then it's intuitive to know. So the z-score is whatever x is minus whatever the mean is, average, divided by the standard deviation. So you don't have to memorize a formula rotely once you understand it. Once you understand what it means. Anyways, box over. We can continue.
Okay.
No, that was helpful. That was helpful.
Yeah, that was nice. Okay. Question 7. So what we're on.
What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE?
So is this the one where you do 160 minus 150 thing? Or am I mixed up?
I thought that was the.
Oh no, I'm wrong. I think. Okay. Yeah, okay. So we have the z-score already. So we can just... So is it 0.1? Are we doing 3 decimal places? what I got, 0.148. Maybe I'm wrong.
That was under the.
So don't we need to find the z-score first?
We already did.
Good.
Oh.
It's the question for that. Or no?
Tells us the z-score of scoring
So was that
160.
Yeah.
1.045?
1.045, yeah.
Okay.
0 point.
And then we would just plug the z-score into the applet, right?
And we go for the shaded portion above the line on the right side.
Yes. I think so. Like, was it 0.1492?
What did you get?
I think it's 0.149
How are we
because
so
it's
so far?
score above 160.
Right.
There it is.
I got 0.148.
I got the same
I
as you,
messed up
Crystal.
on my z-score,
Oh.
I think. Yeah, 0.148. Sorry.
Yes. No,
I put the wrong number in my z-score.
1.48.
So essentially what it's saying, if I understand this right, is that it's a 14.8% chance that a student will score above 160. Is that right, you think, guys?
Yeah.
Yeah.
Okay.
Now, do you guys have any questions about how Cameron did that? Because if you have any questions at all, this is a good time to ask, because next week we have a test on this.
Oh, no.
Oh, so the test is next week. I was wondering.
Uh-huh.
So 14.8 would be it's just converting it into percentage.
Mhm.
What's your question?
No, I was saying that the 148, what Cameron was just saying, you're just converting it into a percentage, if that sounds correct.
Yeah. 1 second, sorry.
Okay. Are we good for question 7?
Yeah. We put 148. 0.148.
Yeah, 0.13.
A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample means of these students' scores? Round your answer to 3 decimals. Example. Here's an example. So is it just adding them up then, and then?
No, the mean. Oh, yeah, you're right. My brain. It's finding the average.
The average. That's right.
Mean is 160, so then it wants to know the z-score. Mean. As my computer loads. Maybe it won't load.
It's like,
Jared, do you want to walk us through your thought process as you're working on this question?
What?
It might be helpful, Jared, if you walk us through your thought process as you're working on this question.
Well, I'm trying to read through the question and get the formula. To say
Uh-huh.
you have to I think you have to average the 5 numbers, but then after that, I'm trying to remember if it's z equals the x bar minus u over or divided by the I don't know what that is. It standard deviation, the O thing?
Yeah, you're on the right track. That was great.
Divided by n, right? Or a square root of n, correct?
Huh?
But I'm just confused because I just don't know where all all the numbers are at. That's how to place all the numbers.
Okay. So you're right. That is the formula we use. Let's look into it a little bit. Let me bring up the right lesson. What lesson is that we learn about these? Lesson 5?
It's lesson 5. So you want to find the standard deviation of those numbers. You want to find the mean, and then you want to apply those into the z-score equation, essentially, right?
Yeah.
We're doing here. Okay.
Okay. I'm going to share my screen for a second. We can talk about this.
Okay.
Share. Everybody see?
Yes.
So the formula that we first learned about z-score is this one, right? Z equals x minus mu over sigma, right?
Mhm.
So in English, this is z-score is equal to whatever number x we get minus the mean divided by the standard deviation, right? Then we learn later on, they kind of throw us a wrench. We have like a sample and not just one. When we have more than one like observation, we have a sample. We learn that the standard deviation of sample means is sigma divided by n, square root of n, right? So are we all with us together right now for this one so far? Those two formulas are just from the textbook. We have this one for the z-score, and then we have this one for the standard deviation of sample means. Everyone with me?
Yeah, so far.
Yeah.
Really, if you look at it, so the only thing that you have to really know is that when you have one, you use this formula. We only have one observation. You use a simple formula. Z equals x minus mu over sigma.
Mhm.
You have more than one sample. Sorry, when you have more than one observation, you just have to replace sigma with sigma divided by n, the square root of n. So instead of sigma over here, you put in this.
So did anyone get the z-score yet? So I can check my answer.
No.
No.
I'm like almost there. I've seen it. One thing.
I could be completely wrong because it's kind of a really big number
It shouldn't be.
that I got at least.
It shouldn't be a big number.
I didn't think so. I got like negative 15.4.
Let's kind of together. So we
Wow.
have the mu is 150.8, right? The sigma is 8, right? Let's see what else we have. Calculated the average. So call that x bar.
Wait, where did we get 150?
50. That's from the beginning of the question. That's from before, just above question 6.
I have totally left that out. That's why.
Oh, okay.
Got it. I
So it's
forgot.
just
About
like
That's how I'm not sure where all the numbers were coming from. That's
Oh, we were still talking about that one?
Yeah.
We're
Oh,
getting
my
that information from above to this. That's why everything's screwed up.
Oh, okay.
that's why I'm lost. I'm
Okay.
like, I don't know what's going on anymore.
I knew the number was wrong because it was huge.
So I get, is it easier? Do you know how to do it now that you have the right numbers?
Well, the right numbers are definitely helpful.
Yeah.
Okay. All right. Let's see you do it.
Let me come down and see what we got now. Okay. Okay. So the second one is so it's 169.8. Let's see.
Okay, so I did. Okay, here's my equation, and I may be wrong. So I did. Hold on, wait 1 second. What's the question asking?
What is the z-score of the
Okay,
sample
so
mean?
I may be totally wrong, but I did 160 minus 150.8
That's okay.
over the standard deviation of those 5 data points.
That's right. What is the standard
That is
deviation of those 5?
It's 8.9888882. Is that right?
No.
Son of a gun.
10.049875.
That's what I got. 10.049 blah blah blah.
Son of a gun.
Well, if you're running three, but if you're running it to 3 decimal points, it would be 050, right?
No.
I think it would just be 04. Oh yeah, 05.
Oh wait, I did the wrong one. You got 10.05 for your
Yeah.
standard deviation. So then, what did you guys get for
Standard
your
deviation.
score?
Number.
I got
Got
0.915.
What did you get?
0.915.
What equation did you use again?
I did so I did 160 minus 150.8 divided by the standard deviation, so 10.05.
Okay.
Or yeah.
Yeah. But you said you got 0.915?
Yes.
That's what I got too.
Yeah. Is that are we doing that right then, Jack? Is that
Is 0.915 your final answer?
sorry, what was that?
Is 0.915 your final answer or your standard deviation?
My z-score, my final answer.
What did you get for your standard deviation for your S?
10.05.
No, that's too big.
Son of a gun. Okay.
It's too big?
Yeah.
Really?
All right, I'm gonna screen share and
You-
let's talk about what Cameron's doing wrong.
No. Let's look at this. Let's look at this from the wiki. Law of large numbers. This is lesson 6, section 5. Let's see if the highlighted part helps at all.
Oh, I think I'm gonna be wrong.
So when we had a sample of 1 with the last question, when we had a sample of 1, the standard deviation was 8.
So it should be
Now we have
smaller.
a sample of 5. Sample will be bigger or smaller than 8.8?
It
The
should be
bigger
small.
sample size have a smaller standard deviation or a bigger standard deviation?
Smaller.
Increases, but then it says right there.
The standard deviation would decrease if the number of sample, like the amount of the sample increases.
Yes. So with 5 samples, you should have a standard deviation that's smaller than 8.8, right?
Right.
So
No.
what's the formula for that?
That should be the formula right there.
Yep. So what's sigma? Sigma is 8, right? What's n? What's n here?
So n is 5,
Uh-huh.
right?
Square root of 5.
So the standard deviation is 3.935?
Yep, exactly. So we have R is 160. That's the average of those 5 numbers. S, which is the standard deviation of those 5 numbers. A sample of 5 is normal standard deviation divided by the square root of 5.
Yeah.
Then it's 160 minus 150.8 divided by 3.935.
Yep. Got it.
So it's 2.338
Huh?
would be our answer here.
Yeah.
Okay.
1.3.
Sorry, real quick. What formula are you guys using on Excel to find that standard deviation?
Which standard deviation?
What was that?
Which one? The population or the sample standard deviation?
Of the five numbers of 5 sample size we have.
So it's this formula right here. So it's population standard deviation divided by the square root of sample size. It's the square root of n, which is 5 here.
So it's not just normal standard deviation like st.dev.s.
Yeah, that makes sense.
It's different.
Oh yeah, because it's a smaller sample. Okay, yeah, I get it.
And that formula comes from here. It comes from lesson 6.
Makes sense.
Here.
I get it.
Jared, Ellen, if someone will have a question, will ask a question about this, what question would they have?
What?
If someone has a question about this, what question might they ask?
I don't know.
What kind
Trying
of
to
questions
just-
do you guys have about this?
Oh my goodness, it's all making sense.
Yeah, isn't it all like compiling?
Frustrating but good.
So essentially, the reason why we use this equation is because it's like, we're using the parent sample information that we've been given and working with that down. So instead of using the traditional standard deviation equation, we're using this because we're basing it off of a parent sample as well.
Yes, exactly.
So there's two samples, so you use it.
Yeah, I pay for it. I pay for
I
it.
signed for it.
Okay. Oh, thanks. Exactly.
Okay, so real quick, what was your z-score then?
2.338.
Church is true. Ah. Got it. All right. So is everyone kind of on the same page with that then?
Yeah.
You got
Yes.
it, Jared?
Yeah, I'm better when I it sounds weird because I usually I'll spend a lot of time going over the formulas and then plugging it in myself and messing around. I don't do well when I have to try to speed through to figure them out.
Yeah, I'm the same way, Jared. So
It's tougher for me to like in a group setting because I always struggle because I have to remember what the formula is and then go back and then I mess around with it for a while until I eventually get the right answer or think I get the right answer.
uh-huh.
I tend to struggle when it comes to the
Yeah.
possibilities.
I was actually pretty bad at these group meetings because I would always insist on like doing the questions on my own first, and then if I had questions, like I would have to like do it first and then explain to people. I can't think while I'm talking to other people.
Yeah, and I can't, and it's hard for me to focus on what it is I'm having to look for when I don't. You know what I mean? But
Yeah, I definitely understand. Okay, you guys want to move on to the next question then?
Yeah.
Yeah. Let's do that. Okay, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Round your answer to 4 decimal places. So is this one using the applet? Essentially, we're going to put in the z-score and do greater than?
Yeah, that sounds like it.
7
Yeah.
o'clock.
oops, sorry.
7 o'clock, guys.
7 o'clock here, not there.
It's 8 o'clock here now. Okay. So I got 0.0097.
That's what I got.
Yeah, so we have to round it to 3. Point
0.010.
010, right? Yeah.
010.
Would that be correct to round it to that, essentially?
Yeah, that's fine.
Okay. Oh, this says 4 decimal places, not 3.
Oh, yeah.
Oh,
So we
tricky.
want 0097.
What did you say it was? 0.0097?
Yeah.
Now compare like question 9 to question 7. Question 7 is 160, right? Question 9, we're talking about 160 as well. Right? The score that we're looking at is the same score. But now that we're asking for 5 people greater than 160, probability went down by a lot.
Yeah. That makes sense.
So the 7 was basically any one student, and 9 we're looking at any 5 students, right?
5 students together have the average of 60.
Yeah.
We're like, wow, those 5 people are really good.
Freaking geniuses, man. All right. So move on to 10, you guys. Are we ready?
Yeah.
Ready. Let's see.
Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of 81 students will be drawn. What is the shape of the sampling distribution of the random variable mean, which represents the sample mean of the 81 students who are selected? Okay.
So essentially, we need to determine if 81 is large or not.
I would think that is.
If it's a large sample, then I think it would be approximately normal based on the theorem thing. I don't remember what it's called.
I think so, yeah.
Yeah.
Theorem of
Central
whatever.
limit theorem.
Central limit, yeah.
Yeah, exactly. Got it.
Nice.
So what's the final answer?
Normal?
Normal.
Normal.
Yeah, because
Normal.
rule of thumb given to us is 30, and
Um,
81 is all above 30, so it's approximately normal.
it's nice to know because I was just guessing. So if it's above 30, it's large, essentially.
Yeah, that's the rule of thumb. It doesn't actually work quite as well in the real world. There's more nuance to it. But for the purpose of this course, you just have to know compare it to 30.
Okay.
Yeah, I think he said it in the reading. I don't remember where, but it said something about 30. That's what they're going to use for this class.
Yeah.
Okay. That's nice to know. I didn't realize that.
Alrighty.
Okay, 11.
Someone, yeah.
What is the mean of the distribution of the sample means, sampling distribution for all possible samples of size 81 that could be drawn from the parent population?
What's the mean distribution of the sample means?
What is the mean distribution? I don't get this question.
I don't get this.
I don't get where
I was
the
just gonna
size.
say, no idea.
And that's what I mean when I say like this class is kind of like a language class.
Yeah.
You just have to one of the biggest hurdles is understanding the language of it and being comfortable with it.
So where is the term size coming from? Because I was under the impression we were going for GPA. Is this like the sample size? So 81 students are being sampled? Is
Yep,
what it-
exactly. The sample size is 81.
Okay. I got, in my head, I don't know what I was thinking. Okay.
You're thinking
So
dress
from-
sizes?
That's seriously, I was like, that's a huge size. Like, I don't understand what's going on.
So is it 3.5?
No. Okay.
Because you-
So
It would be
this is that
2.
equation we learned from this past one, I think.
The
So
one-
a random sample and what is the mean of the distribution of the sample of means for all possible samples that could be drawn from the parent? Simply just 81, or is it simply 3.5?
Well, which one is it? What's the question asking for? Like, explain it to.
It's asking for the mean.
Yeah. And it's saying the
The
sample
mean
size is
of the distribution
81,
sample.
which is the sample size that they gave us in the instructions and the information.
Uh-huh.
So essentially, it's just asking us to tell them what the mean is.
Yeah,
Right?
exactly. Mhm.
Bah humbug. This is crazy.
So that's what I mean. Like,
Where this is it's easier
Why
than
can't you say, what's the mean?
no, well, it has to be very exact in the language because there could be. I mean, we say mean so many times in this course, right?
Yes.
So that's why the question is more like a language question. You just have to understand what it's asking for. The concept is really easy.
You just have to work through the question in your head to figure out what it's asking.
Yeah.
Language is very important. So
81, is that what we said it was? Sample size of 81?
All right.
What do we
Do
get
you
for that one?
Terry?
No.
Okay, so essentially it's asking, it's saying it's asking for a sample size of 81.
Correct.
In the information above that it gives us for like the umbrella of all the questions below it,
Uh-huh.
sample size is 81, and the mean of the sample size of 81 is 3.5 already.
Uh-huh.
hold on.
Question 11
Correct
is
there.
just asking us that.
Let me correct you there, Crystal. The mean that it talked about in the information is population mean. 3.5 is the population mean.
Also the same thing as the other mean as well, because they're the same thing, right?
Yes. Yes.
Yeah.
I'm not good. So then it's 81 then. Because if it's saying if the mean of the distribution of sample for all your possible samples is the size of 81.
81 is the sample size.
Not the mean.
So the question is going like this. It's saying BYU Idaho students, all the BYU Idaho students, their average GPA is 3.5, okay? So the parent population is BYU Idaho students. And then they're going to say, so we're going to take random samples of 81 students. Just 81 students at a time.
Mhm.
And so there's going to be like probably like millions of samples, right? Millions of different samples that are possible to draw from like the pool of BYUI students, right?
Mhm.
Now, if we take all those millions of samples and take their mean and put them together, or like average them together, that final average sample means it's gonna be 3.5 always.
Okay. 3.5, that's how it calculates out to.
Yeah.
Mm.
You take the millions of samples and average their sample means together, it
Yeah.
always equals to the population mean, 3.5.
Good.
I think I'm good.
I'm good.
I'll work on it when after class.
And that's called the law of large numbers.
Is the next one the same? Words? I think so.
I feel like it's the exact same thing, but just for the standard deviation.
Yeah.
I think
Let's look at it. Let's look at it.
So what is the standard deviation of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population?
So
That's for standard deviation
Uh-huh.
from the distribution of the sample means for all possible samples of the 81 that we drew from the original parent population, which was also 81, right?
No, original parent population is all BYUI students.
Oh, okay. I get it. Yeah. So it is 0.7,
That's what I think.
but it's 0.700 because you have to round it to 3 decimal places.
No, it's not 0.7.
Oh my gosh.
It's not.
I'm gonna die.
All right.
I will. So it looks like you guys are having trouble with lesson 7. So not lesson 7, lesson 6.
Well, the
Earlier
funny
this-
thing is, the last one we got, like, we understood everything, I felt like, last
Yeah.
week, or Tuesdays.
I think it's just the wording that's getting us.
Yeah, it's possible.
Because it's exploding now.
So it's going back to this
Yeah, the
concept
last-
right here, the law of large numbers. So if you guys want to open up lesson 6 and go to section 5, look at the law of large numbers.
Right. So the mean is getting smaller. No, it's not.
Mean is getting closer to the true mean.
Right.
Then
What is
it's,
it?
That's the, yeah, law of large numbers. That's where it gets closer to the norm, where it's more normal, right? Or-
Yeah. And no, law of large numbers is where the mean gets closer to the true mean.
Yeah.
And then what if it gets closer to the true mean, what does that mean about the spread or the standard deviation? What does that say about the spread?
It gets smaller.
Yeah, exactly. So as sample size increases, you get closer to the true mean and you get a smaller standard deviation. So what is the standard deviation here for this question, for question 12? It's the parent standard deviation, 0.7, divided by the square root of the sample size,
Oh.
E1.
So, okay, I think where I'm confused is because in the information, it's saying that the sample size for the information is 81.
Uh-huh.
Oh, it will be drawn. So that all the students is 3.5, and the standard deviation of all the students is 0.7, and then it's saying like the samples.
Yes.
81.
Yeah. So anybody have the answer for that?
That far yet.
This formula again.
Yeah. Okay. I was just grasping the. So. 0.7 divided by. So is it 0.077? 78? That would not be smaller. Yes, it would.
That's what I got. 0.07.
0.078.
Yeah.
No?
I got 0.956. Maybe I did it wrong.
So it's essentially it's 0.7, the standard deviation, divided by the square root of the sample size, which is 81, right?
Yeah.
So it's 9. So
And so
0.7 divided by 9.
0.0.
Mhm.
There we go. I don't know why I did it wrong before.
You got it?
I got it.
Is that kind of making sense, Jared?
Yeah. Like I said, I'm not. It's better. Like I have to write it all down on paper first.
Yeah.
I can't even. It takes me longer than normal.
Mhm.
Well, what is normal?
That's true.
According to this, not very.
I think we're like the slow pace group out of all the groups in the class. But that's okay. I like that.
I think it's good. I think it's good that you're working through the question more thoroughly, and it's not a slow pace at all. This is a pretty regular pace.
Good deal.
The answer we got, I think, was 0.0778. Correct.
Correct.
So we got.
Right, but you
Yeah,
want to
round-
take one more decimal away because I think it's 3.
0.078.
So it's 0.778.
0.078.
0.078.
Okay, 0.078.
Should we move on to 13?
Sure.
Okay, so
What is
we're wanting
for
to
81
find.
random selection BYU students with less than 3.3?
Sorry, I'm processing. I didn't mean to.
Did Jack disappear?
I'm still here.
He just
Okay.
has a screen
Oh,
shared,
sorry.
so it's fake.
I thought
Just,
I
I
feel like
don't
it's
want to
like
put the camera on.
9.
genius.
Okay.
Then probably the mean GPA for 81 selected BYU 3.
So it would be. We want to find the z-score.
Yeah.
Oh.
I would write mine out because I feel like it makes more sense.
Mhm.
Yeah.
So would this be the equation on that?
Loading, it's loading. I can't see it.
Son of a gun. Sorry, my handwriting's awful.
That's exactly what
So
it
the
is.
z-score is equal to 3.3 minus 3.5. 7 being the main deviation over 80 square root of 81. That's the sample size we're looking at. Is that right? Because it's saying like, hey, what's the chance that all 80 are going to be at 3.3? Is that right? So,
I have no idea. Let's see. Okay, so if that is right, I got a z-score of negative 2.57.
yeah, me too. And that would put the probability at 0.0051. I think.
The z-score sounds right. I didn't check it yet. The probability sounds wrong.
I got
The area. So I put at the far
0.99.
left. And
Sounds better.
0.995 is what I got.
Yeah.
You want everything to the left of the right red line. So you want the middle and the left section for your area to be highlighted.
so why would it be that? Because doesn't it say what is the probability that the mean GPA for 81 randomly selected BYU Idaho students would be less than 3.3? So my thought that it would be just the left one because that's a small. Because the main mean GPA is 3.5.
Oh, sorry.
So
You're right. I was reading the wrong question. I was reading question 14. So we're on question 13, right?
what was that? I didn't hear that.
Yeah, we're on question 13. So that is right, just the full left side.
Yeah. Uh-huh.
Good. Okay. That made more sense, but you said it was
0.51.
0.0051.
Yeah.
Bingo. We're getting it,
So
guys.
it would be just 0.005 for the answer.
Yes.
3 decimals, yeah. 0.05. But instead the 1 on there.
So on this next one, would it just be the same thing? No. Nope. Kidding.
What is the probability
Hit the
mean greater than 3.3? So it would be the same z-score, but the probability would be 0.995. So this one would be
Yeah. The right of the red line and the middle, right?
Mm-hmm.
Yes.
0.995.
99. Yeah.
What was the z-score again? I forgot.
Z score
the
is 0.571.
negative 2.57. Oh, this is a long question.
Guys, let's just rip through this.
We're almost there. Last question.
Okay.
States Coast Guard.
The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but raised after a tragic boating accident. Standard deviation of a passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is extreme or more extreme, below the mean, that was observed in the sample. Note, as extreme or more extreme means that we're interested in values that are lower than the ones we observed, but also as far away from the mean as ours in the positive direction. Okay, I gotta hash this question out really quick.
Okay.
Okay, wait.
Let's think. Okay, what is it asking for? It wants the probability that a random sample of passengers will have a weight that is extreme or extreme.
Yeah, so their
In this,
their assumption is that the mean weight is 185 pounds. And the standard deviation,
it's 26.7.
26.7 pounds. Now, their sample, so that's the parent population. Then the sample is of 48 passengers.
You're doing great so far.
And the sample mean of that was 177.6 pounds. So we need to find what the standard deviation of that sample would be, and then the z-score, and then the probability, essentially. This is just applying everything we just talked about.
Exactly. Technical.
Okay. So, 170.
So we're assuming that the mean is 177.6. Is that right?
Yeah.
What is 177.6?
Because it's saying here that then was observed in this sample being the 177.6.
Yes.
Okay.
So that's our sample mean.
That's our sample mean. Okay.
Okay, so negative 1.92.
What's that?
I think that's the z-score. So then, the probability is on both. Okay, so I got the probability of 0.055.
Oh boy. Could you can you just kind of walk through how you did that?
Yeah, could you please, Crystal?
Did I get it right?
It's the right answer. It's the right answer. Walk us through it.
Oh, Jesus. All right.
Okay. So what I did is I used the equation that we did in the previous question to find the z-score. So I did the mean of 177.6 minus the population mean of 185.
Do you have a?
That's good.
Did you
Okay.
write that down, or did you do it on the computer, Crystal?
Well, I have it written down, but it's like my brain writing. So let me write it down that looks better that you can listen.
So I did that, except for I forgot the 185,
Oh, okay.
and that's wrong. Okay, what did I do
Well,
wrong?
let me write it down so you can kind of see it better. Divided by 26.7. So I use this equation to find the z-score. So what that is
Yeah, that's what I used to.
the sample mean minus the parent mean divided by the sample standard deviation over the square root of the sample size. Yeah?
So was your final answer after you put it in the applet 0.055?
Yeah.
Yes. That's what I'm talking about. All right.
Finally together.
I'm really scared to submit this, guys.
0.055. Is that what you said?
Yeah.
That's because you're selecting both of the sides because you want the right extreme and the left extreme.
Right and the
So you're
left, yeah.
highlighting.
Okay. Let me walk through it one more time, just for Jared and Ellen. Do you guys get it, Ellen, Jared?
You know, I got part of. I just had them backwards, the 26.7 and the 48 backwards. So if I had probably put them in correctly, which I said it takes me a little more time, I probably would have.
Yeah. So let me go through it just one more time, for the sake of thorough. So what we have here, I talked about how the mean weight of commercial passengers in commercial boat is 185. So that's the parent population, the true mean, right?
Mhm.
Then it also gave us the standard deviation of 26.7. And that's for the population. So these two are for the population. Then it talked about there's a random sample of 48 passengers. That's their sample size, n equals 48. For those 48 passengers, their mean weight was 177.6. So that's our sample mean. So you guys with me so far?
Yes.
So just getting numbers
Yes.
from the question, and that's probably the hardest part of this question. Getting those numbers, cleaning those from the words. Now, for our sample, we know the sample size is 48. We know the sample mean is 177.6. Now we need to find the sample standard deviation, which is represented by S. That's the formula right here. We have P2. So the parent standard deviation divided by the square root of the sample size. So we get 3.85. Whatever. And then with that, we can find the z-score for this sample. And that's going to be our sample mean minus our population mean divided by our sample standard deviation. You with me so far?
Mm-hmm.
Yep.
So we get this z-score of negative 1.92. And now, what is asking here is, it says, switch to the other window here. It's asking for, find the probability that a random sample of passengers will have weight that is less extreme or more extreme. So either, so right now, so basically we have this right here. This is our z-score, negative 1.92. So more extreme will be going either left of this or right on the other side. So the two tails.
Right.
So you highlight the two tails, you put in the z-score, and you get the probability of 0.0549. You round that to 0.055, and that's our final answer.
Right.
Okay.
So what do you think? Should we try and submit it?
Yeah.
I think we got 100.
You already
Did
submitted?
we?
I already submitted it.
We got 100 on that.
Yes. Got 100. Good job, guys.
Oh,
Oh, mine-
man.
Wow.
Thank you, Jack. I think that was a good day to have you here with us.
Yeah,
Thank you
it
for
was
helping us.
perfect.
You're welcome. Hey, so I'm going to be visiting other groups as well, but in the future, if you guys have any, email me. Also, I'm going to try to have office hours at like, basically in the afternoons and nights. So I think I'm going to try to do the schedule of like Monday night at 9 p.m., Wednesday night, Monday night at 9 p.m., and Thursday night at 9 p.m.
Okay.
So I'll post those on discussions and stuff.
Awesome.
You guys any questions you want. Or if you have other questions, just email me. Okay?
Okay.
All right, perfect.
Thank you.
Hey,
Thanks,
thank
guys.
you guys. You guys are awesome. Good luck on the test next week.
Thank you.
Thank
Thank you.